So hello everyone, welcome to the new episode of TechKraft podcast. I'm your host Ravi Mandal. Today we have a very special guest, Ronak Zala from VMWare. He works in the US and I'd like to welcome him to the show. Welcome Ronak.
Thanks a lot, Ravi, for having me. Yeah.
So Ronak, it's a very unusual way that we got to meet. We actually met in a friend's wedding. And I just saw his profile and what he has been doing, and I said hey, you have to come to the podcast, and that's how we have here. He's flying back today, but I'm very thankful for you to be in this podcast and talk with me and spend your time here. So Rona, can you please give a short introduction, what you've been up to, and how did you end up working at VMware in the US?
Okay. Yeah. Absolutely. It's a pleasure to be here. I'll start off with where I am right now, and then travel back to where I started from. So I work as a performance engineer at VMware, we focus on building data pipelines and analyzing these huge streams of data that we are getting, and to develop insights out of those things. I started off as a very it's a very simple thing that I had in my mind when I was a kid. I got my first computer when I was in 5th, and I think since the very first day, those things always intrigued me. And I think that was the point that started my interest and my passion in computers, or in just these systems, these macros that make your life very simple. So after finishing my high school education in Gujarat, I decided to pursue engineering from the best place that I could in India. And it was very clear for me, what is the destination I'm trying to go to. So I spent a lot of time prepping up to be where I am right now. And the whole journey started from going to Kota. So there's this place in India there everyone who wants to sort of pursue or go to IITs or a very good engineering institute, go there. You have a coaching base set up over there, and you basically rent a room, be there, and all you do is study and prepare for IIT. So we had this entrance exam called JEE, and for that I did my coaching from Kota, from an institute called Resonance. And luckily and thankfully, I got into IIT. So I pursued computer science in IIT Delhi, and that was the beginning part of that thing that broadened my horizon. Because before that, I just lived in a small city in India. And when I went to IIT, I met people coming from each and every corner of India. The kind of exposure that you get, the kind of different styles of thinking that you encounter over there, you get to learn a lot of things, from that sort of setup. For me personally, to be honest, I don't consider IIT as one of the very different places than any other college that you go through. But I think it's more about the crowd that you interact with, the kind of thinking that these people have over there. And I think that is the key about IIT. It's not the college, it's not just the professors, it's not just the kind of education that you get, but it's the kind of people that you're with. Yeah. And when you stay with these talented and these multifaceted people, you get to learn a lot. And because of that, you develop this a very different style of thinking, very critical based thinking. And I think that shapes you up. That is the craze behind IIT. It's not just the college that you go through, but the kind of human that you turn out after finishing your 4 years over there. Yeah.
So after IIT, you went to the US, right?
Yeah. So after IIT, I worked for a company called AppDynamics. It was in a very nascent stage at that point. It was still a startup. And I still remember, it's a funny story. So I got placed in AppDynamics But I didn't even know that, what the company did. So we have these placement thing in IITs where a lot of all the companies come and they interview you and then you get placed. App Dynamics was something that we had no idea about what the company does. But on the first day, it was the interview day, and me and my friend, Divyanshu and I, we had been selected. We had passed the initial rounds of interviews, and we were just going there. We were excited just to be there in the same company. And the more we got to know about what the company does, how crucial it is not to just build a product, not to just deploy a product, but there's a huge part that goes in managing the product and making sure, it stays where it started from. Like you would have experienced how using a Windows laptop goes, right? Okay. The first 2 months are amazing. There's no lag. It doesn't take 2 minutes to get booted up. But after a point, it starts lagging. Yeah. So I think what App Dynamics did was to focus on that part, to keep the system performant and to also, collect insights from there. So at a 40,000 feet view of what App Dynamics does is they do application monitoring. So it's an APM company, an application package monitoring, and they focus on creating these agents that do byte code manipulation of your applications so that you can get insightful data out of that. Now, if you had to do that on your own, let's say you're creating an application, right? And you have to focus on making sure that you're collecting this data at the very same time, doing what the application is supposed to do. So that's an added onus on the developer, on the team itself. So what App Dynamics did is something severely cool. I've never seen that. So they actually do Java bytecode manipulations. So when you have your Java application, right, you have these class files and you create these jars and vars and you deploy them. The company provides an agent that sits along with that jar. You don't have to worry about doing anything else on top of that. But this agent itself, using the Java APIs and the JMX constructs of Java, it does bytecode manipulation at the runtime. So at the runtime, they are able to inject code into your own application and collect these insightful data. So when I first found out about that, heard about that, how it actually worked, I was blown away. Yeah, and the more I got to understand how it works, it's like when something which is so simple and yet accomplishes so many more things, when you understand how it works, it's a journey. It's a revelation about, what complicated things in life, when you boil them down, it comes to very simple things that you do. There are these small blocks that you keep on building on top of the other. And you end up creating this entire system which seems like magic to you.
True. Yeah. So in terms of computers, I've always been very interested in terms how the actual hardware works, right? If you take a PC or maybe a server, there's a processor, there's a memory, there's a hard drive, and everything. We always all learned that in schools. But if you look in a very, very, very small level, very nano level, it's all zeros and one that actually happens there. And I saw a video 2-3 months back when there was a 1-bit flip that happened in memory, and it caused an entire different candidate to win the elections instead of someone who should have won it.
Wow.
Because of a small bit flip that caused due to a cosmic ray, they say.
Okay.
So oh my god, that's crazy. Just because a normal bit flip happened and it changed the entire history of a country or place's election, right?
Yeah.
Now that's where the ECC memory check came in, right? If I'm not wrong, but I would like to know more about bytecode analysis. How does it work? How does it work in a very granular level?
So bytecode manipulation. The word manipulation itself sounds very complicated, but it's not. What they do is that in Java, you have these. So basically, you write a Java application, right? You have your main class that you write, and these classes are then basically generated when you compile the applications. What happens is that these bytecode manipulations becomes a wrapper on top of those classes. So when Java reads those classes, they get sort of wrapped up inside these classes, and these are like helper methods that give you more insights. So let's say you have a very simple method, right? It's like get the next employee, right? What bytecode manipulation will do is create a wrapper on top of that. Let's say you want to measure how much time this call takes. So what it does at a very basic level is have a time call, like timer call, like timer.start. And by the end of it, you have a timer.end, and you end up getting how much time it took. Or let's say you set up a counter at the top of it, and that counter gets incremented. So you know how many times this method was being called. So that is at a very base how bytecode manipulation works. Like you have this wrapper class around your original class, and that gives you insightful data.
Yeah, that's very interesting to me. But I have used some APM tools provided by Microsoft Azure. Like as I've told, like I'm a more Microsofty guy, but yeah, like the level of insight that they give on your application. Like for example, this method took this milliseconds. This method took this milliseconds, and the like when I was working in a very cloud-heavy scenario, like it was so helpful for us. Like it's something that everyone should start looking into. Like if they are not looking into, right? Because it will give you a very good insights on how your application is performing, not just if it is working or not. That's one thing, but how well it is performing, that's another thing that we always need to take care of, right? That's a metrics. Yeah, that's a metrics we always should be looking into. But except of like knowing how many times the method has been called or how many duration it did take, like what else can we actually figure out from bytecode manipulation?
For example, let's say so you can actually do method arguments capture. So you can actually see deeper inside like the parameters that you're passing to the methods. Like what are those parameters? You can have a tally of those things and maybe analyze. Okay, fine, this method was being called, but like what are the other things that are being passed to this? And you can have a chart on top of that. Like let's say, for example, you have a shopping cart application, right? And you want to understand, what is the usage, like how are people making the orders, or how much time this thing stays in the cart before they actually go for the final payment. Yeah. So these method argument collectors actually collect these specific method parameters, and these parameters you can basically, let's say, when you have a list of these parameters that went by during the entire day, like you can develop crucial insights on what things you should be focusing on, how much time people are interested in keeping things just in the cart, and how much time they take to actually buy those things, and what are those things. So
I think like having that method call arguments not just only help us to get the insights on what data is actually being calculated by the method, but also like if you're trying to build a test suite for automated test, like if something goes wrong in the application itself, and you need to figure out and fix it, and also make sure that it doesn't happen again.
Absolutely.
You can take those parameters and like build a test suite out of it and like make sure that it doesn't happen again.
I would actually like focus on that point more. People actually use it for that. So everything is fine till it's running fine. And suddenly when it stops and breaks, it's not fine. And unless you have this visibility onto what happened, you don't know what to do. People end up just restarting their applications. But when you're collecting this data in the meantime, when these crashes happen, or when your JVM crashes, you can actually know what happened, what triggered the crash, and then just improvise your application based on that.
Yeah, true. So like I have a very funny story on like how I used to do that. Instead of using a proper APM like before, like very, very long time ago, someone calls me, says, hey, this is not working. Okay, fine. I need to figure out what's the methods being called, like what are the parameters that are they saying? Are they sending ABCD, or are they sending like Unicode or whatever it is, right? So what I do is I go to code, I read console log, parameter 1, 2, 3, 4, deploy that, and then like tried it again. Then the methods comes in and hey, yeah, this is the parameter that they're setting. Now we'll figure out like what went wrong, right? So that's how we used to do. Now with APMs, the tools that I have used, like it has made a lot of sense for me. Also like help a lot in the productivity of our team and like the way I used to code. But something that I wanted to cover in that particular topic is like for what happens if something like, for example, there's a method called save card details. Let's say you are PCI DSS compliant. Let's consider that, right?
Okay.
You can store card details. If a parameter has a credit card number string, like if you start logging that, how do you handle that? Because we have seen like companies like for example, I think it was Twitter, right? Like they had logs saved in text file. The password saved in log as a text file. Now, no matter what encryption or like cryptographic methods that you use, like if you're storing password in plain text and log, it's not going to work. Like in terms of that cases, like how do you manage for APMs?
Yeah. I think that has become a very big part since couple of years. Since Europe released the guidelines of how applications should be compliant about the user data, how there should be a switch. If the user wants, they can just have a clean slate. It becomes very important that you don't reveal this customer critical information just out there somewhere, getting spewed in the log. And for those things, the onus falls on to the people who are creating these APM agents. So it becomes very critical onto what information you are logging, what information you are having a track of. And to be honest, the answer is plain old Q&A. These people have to make sure that there is no other information which is getting leaked or which is getting displayed. And like basically it's at the end of the day, developers and the testers are the backbone of this entire tech industry. Developers create these applications and testers test them. They try to break it. That is their role. And if they are able to break it, you should not view it as a shortcoming, but rather some bug that you caught, not in production, but in your own testing environment. So it takes a lot of effort to answer your question, and it's not a foolproof idea. Yeah. You have to be very thorough about it. You have to be very, conscious about the kind of details that you're tracking, the kind of these, this, the logging statements and the information that you're storing, So you have to be very conscious about that.
Probably I'm not sure about that because I have stopped coding right now, but I think most of the APMs will provide an attribute saying that, hey, this is a sensitive data, you should not log it. I hope that's a feature that's available.
Yeah. I think they have to keep that.
I think that's but probably there must be something, right? Because if that happens, it's a very crucial part. And this is something that, every software engineers and every developers that work in a company should be very careful about. Like it's not something that architects would come and tell, like, hey, you should be hiding this, you should be masking this data. Like it has to be something that everyone needs to start considering from the day when they start writing code. And yeah, that's a perfect statement for that. So like coming back to like what you mentioned, you talked about like how we should not just like develop an application, deploy it and forget about it. There's an entire life cycle that goes behind managing, fixing and like monitoring the application. Like how does it work as a like let's say I'm a simple I'm a company with a SaaS product, right? Now I deploy a product, like many customers are using it. Like how do I manage the life cycle after deploying the application and the customer starts using it?
Oh man, to be honest, I think there are companies created for these purposes. Like it's kind of bootstrapping them itself. Like initially there was need of having applications, there was need for modernizing these, the things that we did on paper. We created these applications, that work on computers. Now there are companies being created to make sure that these applications work nicely. Yeah, absolutely. For a very let's say, for a very early stage application creator, these companies actually do a big favor by letting them focus on what they are doing, the kind of functionality that they want to provide, and what they end up delivering, giving, is like these out-of-the-box products that you just deploy alongside your application. So they might be just sidecar applications which are running along with your applications, and they take care of everything else. Otherwise, the onus falls on the application developer, and they are not able to focus on what the original intent was for creating the applications. So you have these APM products that give you insight into how your application is working. You have these tracing products that stitch a lot of these of data and give you a nice waterfall model of what is happening end to end. They make sure that your application doesn't remain a black box, but you get visibility onto that. And there are these other companies that provide you this insight into these data being collected. May it be just a very simple example of that would be doing log analysis. Okay, logging is something that almost every application, you need to keep that. But as applications spew out like thousands and thousands of lines of logs each second, and it's not humanly possible to monitor those logs. There are companies that do analysis on those logs. They try to find out anomalies that happen, so that you are notified of these things rather than you have to monitor. And I think that aspect of doing these anomaly detection, may it be in applications or getting the logs or just viewing customer data, that is the insightful part, right? Like when the graph is just going straight, you're not interested. But when you see that spike, that is the place where you have to open up your eyes and focus on what is going right or wrong. And that is, I think, what a lot of companies are focusing on right now these days, like doing these anomaly detection and doing it in as automated way possible. And I think the future industry is going to be focused a lot on that. We have been hearing these buzzwords about machine learning and artificial intelligence, but at the end of the day, we are trying to replace people who can monitor things. We cannot sit around day in and day out and see for those issues or anomalies happening, and we want someone else to do the job. Definitely, you need to have these other sidecar applications that do monitoring of your applications, that give you insight into the data that you're collecting and what is happening.
And alerts as well.
Alerts as well. Oh man. I think one of the aspects that I work on in VMware currently, a huge chunk of that is alerting. Yeah. So what happens is that being a performance engineer, what you try to do is you try to optimize applications performance. A lot of times that is something which is out of your reach, because that application is not managed by you. So what you try to do is you try to provide these insightful data, like you do all this, like you collect all these statistics and you have this telemetry data that you're collecting. Now that is one stage. So basically, if you want to do a debugging or an RCA on an issue, you have this huge pile of data, you have these data lakes in which all these things are stored. But that is not enough. Like the customer or people, they're getting lazier and lazier each passing day. And what they want is, I don't want to look at these things, but do me a favor. Let me know when something goes wrong. And that is where the alerting, part comes in. And the tricky thing with alerting is that you can't cry wolf every time you feel something is wrong.
Yes.
You have to be very, very, very
sure about
it. Yeah, when you're telling someone that there is some issue, you be pretty sure that there is some issue. You don't want to wake up an engineer or, an on-call engineer at 3 a.m. saying that, we might think there might be something wrong, so please go have a look.
Yeah.
Just
So like that has happened to me. Like not exactly inside of like something went wrong in the server itself, but when I was trying out like Linux-based applications in Microsoft Azure, like I don't know, there was something wrong there, but that means it was for the scaling. Like when you know, like when you're like you set a rule saying, if my CPU percentage is more than 80%, like just scale that to one instance, and if it is lesser than 60%, like downscale to one more instance. Now I was trying that, I was load testing and everything. So what happened was the load would go up to 100%, and then it will start scaling. I mean, that's the whole wrong point of like how the auto scale should work. And like, yeah, that can happen in alerts as well. Like if you get a false alarm, you'll not just panic the developer, you'll panic the entire company.
Yes. And I think we all started with, catching a low-hanging fruit. The thing that you talked about, having threshold-based alerts is something which was useful. And it was good because you were notified when things went wrong. But as you said, right, you're not just interested when the CPU reaches 100% or goes to 80%. But it sort of depends on what your application was doing. Let's say if it was consistently at 15%, then it rose to 50. Now, to other people, it might be fine, but to the application developer, that is a cue which says that, something fishy happened over here. Yeah. So having this threshold-based alerts is not useful over there. What you need over there is something that can capture the local changes that happen, like having these moving windows and having these moving averages, and whenever something goes beyond what the normal was for the past 5 days is what you're concerned about. So that is the next level of alerting that even us at VMware are trying to capture. Threshold based like alerts were a thing. They were useful till a point, but that is not enough now.
Yeah, I have seen that happening in like cloud service provider as well. Like usually previously it used to be if something goes X greater than X, then do this. Now it's more about if something goes greater than 20% of average X, then do this, right? So it's more about the shifting the window to a very larger view so that we can detect anomaly, not like a specific threshold, because CPU percentage can go 100% if someone like randomly hits a very high big query. But that could be a very small spike, right? Like if you start scaling and panicking around just because that hit like one time, then like it's gonna be a hazard probably. So talking about the same thing, like I would like to go back on your journey to VMware. Like how did you end up in VMware, and like what's like working as a performance engineer? What's your day-to-day role like?
Okay. Yeah. So we are going down the memory lane.
Yes. Nostalgic lane.
Yes. I think my journey at VMware started from my journey to the States. I went to the States for pursuing my master's in computer science, and it's a very crazy situation out there. So master's generally is a 2-year course, and as soon as you reach over there, as your first semester begins, you have like a month or two. And you've just started learning things, and then you have to start applying for internships. And for me, it didn't make any sense because I'm like, hey guys, I just arrived over here. Let me actually learn a couple of things. Let me spend time so that you can know what I've learned over here. But sadly, it doesn't work that way. So after my first semester, I started applying for internships, and luckily or fortunately for me, my background in App Dynamics, so I worked in analytics team in App Dynamics, and I worked on creating these data pipelines, like big data pipelines, and that was something that they were really interested in. During my internship, I actually worked on creating APMs from scratch. Yeah, so in App Dynamics, I was working in a small team that managed the analysis part. During my internship at VMware, they didn't want to pay App Dynamics. They thought that, you know what, if we have engineers who work over here and if they can develop these in-house tools, then one of the advantages of that, like, of course, like it goes without saying that you'll end up saving a lot of cash, but at the very same time, you can develop tools to very specific need of yours. And that is what we were trying to do. So Uber had come up with this open source project, and they had released it, and it was available to people, and it had a very basic APM agent that they had. It was a very basic Java agent, but that was like we bootstrapped from that. We tried creating this entire agent for VMware, because VMware has a lot of microservices. Like I don't think I even know all of them, but what is missing over there was getting visibility into what was going on. And I think this is going to be a theme for as long as the tech industry is there, having visibility into what is happening, especially at a scale that things are moving right now. It's not just one microservice that you're monitoring. The scale that I was working on was like 1,000 microservices, and you have to monitor that. Now you can monitor these things fine, okay, but to be able to do that in a way that you're not using up a lot of resources, to make sure that your application doesn't crashes just because of the sheer scale, was something that they wanted us to work on. So I was fortunate enough to have a very nice team over there. I had a really good mentor who helped me, build this tool for VMware, and we were actually able to deploy it and test it out, and collect these data like method call durations, or method how many times it was being called, these arguments capturing, and I think that is the point I started realizing that in this jungle of microservices, just creating an application, just running it is not important, but making sure that it scales according to the need is very important. And I think that is where distributed systems comes in. Like it becomes inevitable to think of anything right now in tech industry without thinking how it would scale in a distributed environment. And just being an intern, it might seem overwhelming to you, but I said, like, you start off with a Hello World program, and you end up creating these entire big operating systems altogether, right? I think internship was my building block at VMware. I got to understand the products of VMware, what kind of service that they were providing, and what kind of services that they needed, or which needs to be there so that they can keep on providing those services.
So does that mean like you started working in a Scratch project at VMware and that's running in production right now?
That is correct.
Oh my God. Like that's a dream.
To be honest, I think the kind of freedom that I've gotten at VMware, the kind of projects that I am able to work in, the kind of innovation, or the kind of a lot of people, when you are given a project, or when you have a small milestone to achieve, there are like 10 different ways to achieve that, and there are like very tried and tested 3-4 ways which generally people prefer. But what VMware, or my team, to be specific, has provided me is that freedom to be not afraid of these things. You can take your time. You can research about what is going on right now around the world. What are the frameworks? What are the different projects or applications that you can use, and that could provide more functionality at the very same time. Keep your applications very simple. And that to me is something that I wake up to every day. These open challenges that you are allowed to tackle. They make sure that you are not being stressed about it, and it's fine if it doesn't work. But when you get that freedom, you can't sleep at night, to be honest.
True. I felt that like if you have enough flexibility to implement your own ideas, and like and you are appreciated to be failed, you try to make better products and better innovations, right? Like I have seen that happening to me. I have seen that happening to many other colleagues that I've worked with. Like, and that's the dream team that I want to build. I want to give them enough flexibility that they will be happy to fail and excited to fail every time, so that they can learn and like make better innovations. So like I really like that the idea, and I'm still stoked about the fact that the application that we built from scratch is running in production in VMware. Just 2 years, right?
Just yeah.
Oh my God. All right. So there is one thing that you mentioned with sound, like very interesting to me is when you're building an APM based product, there has been instances where like I spin up a Kubernetes cluster and then I install some monitoring tools. My application is taking 50 MB memory and the monitoring tool is taking 200 MB memory. I mean, what? You are taking more resources than the application itself. And I think having that as a very core thing, like even if you are someone who is looking after other people, you also need to be very thin, and like you also need to be lightweight.
Absolutely. I think it is one of the most important aspects that we at VMware focus on, is to make sure that the tools and the services that we provide have the minimal overhead on the existing applications. Yeah. Otherwise, it's just useless, right? You don't want to have your monitoring system creating loads on top of your applications, right? Then what are you supposed to monitor? Like you'll have a third application monitoring your first application. Yeah, that just doesn't make sense. So having this low overhead about everything, about the data that you're collecting, or about the data ingestion that you're doing into the data lakes that you have, it becomes very important that you're optimizing on each and every aspect that you have capability, or you have the tools to make changes to. And I think 50% of my time actually goes into that. Okay. The services or the tools that we as a team have developed, most of the time it is thinking about re-architecturing it, making sure that if this loop doesn't needs to go about 50 times but 40 times, that maybe it's worth to look into that, because you have to save each and every CPU cycle that you can to give the best possible advantage. So I think that is a very fine balance that you need to maintain over there in order to give the service that you want to provide, but at the very same time not to hamper the existing application which has been running. I think that's a very, very important point. And I think that, a lot of people miss out on that. A lot of people create applications, a lot of companies create applications, but they stop optimizing it. Yeah. This word optimization becomes very crucial in our tech industry, because we know that, the resource constraints are getting, lighter and lighter day by day. It was impossible to have a computer with 16 gigs of RAM. And now you have a smartphone which has like 10 core processor along with 16 gigs of RAM, right? So it's not that we are going back to the Stone Age. No, we are not. But at the very same times, the applications are scaling. They are becoming so complex that they require these resources. And it is very important for the developer to focus on optimizing each and every loop that you get. Yeah.
So like you work on a platform where it actually monitors other platforms, right?
Yes.
I'll ask you a very dumb question. Like, how do you monitor your application? That actually monitors other applications.
I'll go back to app dynamics for this. So we have these agents that we deploy to monitor
your agents,
to monitor our own agents.
So that is monitoring other services.
Yes,
okay.
yes.
Okay.
So at the end of the day, it does fall onto humans. You cannot have a magic wand which could do everything for you. But I think the analogy that I would like to refer over here is how you have these pages, like these memory pages in operating systems, right? Like you have a two-level paging system that helps you cover a lot of ground. It's like a tree. You have one root node, and then you'll have 10 different nodes. But now you have the advantage of having 100 different nodes on the next level. You need that root node at some point. But this you can keep a very high branching out factor, so that you are able to cover a lot of ground.
That sounds interesting. So, I'm still thinking, like, you have an agent that actually monitors the other agent, and that agent is monitored by other agents. It's like the back where, like, if you need to compile the application, who compiled the first
application for you? It is the chicken and egg problem.
It's a chicken and egg problem.
Absolutely.
It's very it's a scale that application performance and like application performance management is something that I was very, very interested in from the very beginning, and like this conversation is like it's a dream to me to have to work in that scenario where like you can build an application performance management tool. I'm someone who always thought, like, I don't want to use IDE, I want to build IDEs. So I want to build tools that actually help others to build other applications. So I'm someone like that, like very, very...
There's a, like how we have food chain in our ecosystem. In the computer ecosystem, this becomes the hierarchy. You at the very top level, you have the application that provides features to customers, and in the lower tiers you have these monitoring applications, these analysis applications that provide you crucial insights so that you can keep doing the work. Yes.
True. So I'll ask you a very, very technical question, because I know you're the perfect person to answer this. That's about the memory leaks and garbage collectors. So, like, for example, something happened, like my memory percentage was 20% for 1 week. It went to 40% for the other week. Then it went to 60% for the other week. Then like 80% to the other week. I can see a gradual increase of the memory. That means the resources that I allocate is not being collected from the garbage collector. I think I know how to fix a memory leak, but it's always it's something that always goes wrong. Like, I cannot figure out what's going on and what's happening there. But I think you'll be the perfect person to answer this question. Like, how does it actually happen, and what does happen in the internal level of a memory that actually causes the memory leak?
Oh, wow. If I had a solution for the question you asked, this world would be a very different place right now. But I'll share you an example that we recently encountered at VMware. So we have these collectors that collect data for different components, of VMware. And these collectors are supposed to run every 5 minutes or every 2 minutes. Like, we have these collector durations, like they run at the frequency of, every 5 or 2 minutes. And what we started noticing was that one of the largest customers that we have, their collectors started running at a duration of 2 hours.
Mm-hmm.
And when you are supposed to collect data every 5 minutes, which is very crucial, and you are supposed to store that and create alerts based on that, if you just have one data point for 2 hours instead of having, 12 data points, you screwed. And we didn't know what was happening because everything was running fine. So instead of getting data at 5 minutes, we were getting data at 2 hours. And nothing was crashing. Everything was just there. And, we were just looking into stats and we were not knowing what was happening. We tried to debug the code. We tried to, go through the logs and everything. And there was this sneaky little guy, just sitting in the corner of the dashboard. And that was the heap usage. And the heap usage had been stagnated at 100%.
Okay.
So the memory was not leaking anymore. But the memory was not even getting freed anymore. And it was just there. And because of that, like, these threads were, getting stalled and they were taking a lot of time to run. And that was the reason for the collectors taking a lot more time. And the tricky part about this is that you don't know what is going on, because you have this code which is running perfectly for 100 other customers, but for this very customer, nothing's happening. So then we don't know why the garbage collector is not kicking in, and why the memory is not being freed. And one of the solutions for that is doing the heap analysis. So you take a heap dump of your application and you just go through that. It's basically like you take a snapshot of what your application was, like what state your application was in, and you basically sieve through each and every aspect of that heap. You try to see what objects are, taking the hugest amount of space, and then you try to look into your own code. You see why would that happen in the first place, and it is something that will not happen always, otherwise it would have been caught at the testing time. But what has been very useful to us, like what happened to us, is like when we started digging deeper into the heap, we found that we had this queue that was supposed to be freed. And it used to get freed, but the issue wasn't even of freeing up the queue. The issue was of the queue size itself. Because you had a huge queue size, there was no need of freeing the data that was getting in the first place. And because we never had a customer who had such a huge scale, the queue never got filled up. So it wasn't a memory leak. The garbage collection was not the issue. And the heap was getting stagnated, and the collectors were not running, was just because
allocation of the
it was just queue.size which had to be changed at the end of the day. And like I talked about it in 5 minutes. But when you're actually there, when you're trying to debug and when you're trying to look at each and every aspect, you end up spending 2 months. And then when you get this parameter is what the issue was. Oh man, you remember God a lot of times. You start questioning why he created what he created. Yes.
So did it really take you 2 months?
It did. So I was the sole engineer who was working on it. And as I said, like we have this huge collector that collects the data. We have a data pipeline that sends it to this time series database, which has this, on which we have these dashboards that show what is happening. So you have to, check each nook and corner to see where the issue was lying in the first place. And yeah, it was in this queue.size.
Oh my God, that's a different level that like you guys work on. I really appreciate it. I'm really grateful to meet you. Right? But like to the audience of like of a very like a person who actually develops applications rather than building applications that actually looks after applications. Like, could you please explain like how memory works? Like, if I say var, or like, not bad. Like, if you talk in Java world, like let's say integer, I don't know Java, so okay. If you say it's integer or like allocate like 32-bit integer, like how does it allocate in memory and how does it actually free up? Like when it's needed to be freed up. It's a very basic concept.
It's a very basic concept, yeah. But I think these basic concepts are the things that differentiate a very good programmer from a decent enough programmer. Java in itself has two sort of memories. One is called a stack, in which these program counters and these method calls get stacked up, and you have a heap. Where you just store these details, these information that your program needs. And the stack is a very limited space. You would have heard about this amazingly useful website without which us programmers would be lost. Stack Overflow. There you go. And that thing is very crucial. If your stack overflows, there's nothing you can do about it. So you'll have a stack size of like maybe megabytes, very low megabytes, and you'll have this heap size that you can keep in gigs. Java was created with this intent that the user doesn't have to do memory management. And because of that, you have these different garbage collectors which are there. And the function of, like, the purpose of having these garbage collectors is to make sure that the memory from the heap gets cleaned up. The variables, the methods that you don't require don't stay in the heap, and they are freed so that new things can be allocated to the heap. So Java does a very amazing job of automating that itself, and things stay sane, but nothing is as good as it seems. And you have these issues where you'll have stack overflows, you'll have these garbage collectors getting stuck, your heap getting overflown. And I even had an experience with a Stack Overflow issue.
Really?
Absolutely. So I was trying to experiment with this new framework. Like you have HTTP clients, right? You have the Apache client. You have the async, like the sync clients and the async clients. There's a new paradigm that is evolving, which works on. I forgot what exactly it is called, but the client that they have is called a web client, and this web client works on this notion of it's not based upon async or sync, but it is an event-driven model. Yeah,
I was about to say, but I was not sure about that.
Yeah, so it's an event-driven model, and I was trying to experiment with that, and we had this, and these things are getting so so amazing that these clients give you out-of-the-box functionality for monitoring the calls that were happening. So you can get to know that what different HTTP responses you got, how much time your HTTP calls were taking, what exact endpoint is being pinged and how many times. And one of the calls in this was to log all these things. And what that was doing was, when you create this new web client, they create this new logging facade that goes and stores this thing. And because I was new to this web client, the web flux part of Spring, I didn't know that you don't have to initialize it each and every time. And there was this logging call happening at each and every REST call that was being happening to the application. And like after every 2 or 3 hours, the stack would overflow. And we had no clue what was happening. And one of the reasons for that was the logging call that we were making was being made at debug level. And the logging level that we had set was just warning. So in Java, basically you have these different logging levels, right? And you can set, like, you just want the info logs, then you have the warning logs, then you have the debug logs, and then you have the trace logs. And this log call was the trace log, and we had turned the trace off. So it wasn't getting printed, the logs were not getting spewed, but at the very same time, the stack was, being overflown because of this call.
So you are like initializing the logging client for like every time?
Every time, yes, yes.
So when you talk about memory management and how things are allocated in an application, like I figure out this is in a very hard way. Like how not because I had a memory issue, I had a network protocol issue.
Okay.
So in ASP.NET, I was working in ASP.NET, and like we were supposed not an ASP.NET, I think it was a C# console application. So we were supposed to make HTTP calls to a different third-party service. And we were creating HTTP client every time. Now, how it works in C# is when you create an HTTP client, it freezes up your, what do you call it? Something in TCP protocol. I just forgot the name. So I don't know. It freezes some packets or something like that. So yeah. So like I exactly forgot the terminology for that, but every time you do that, like it will freeze up the entire stack, and then like you'll stop create, like the calls will not even be made to the HTTP client, HTTP server, or even if it happens, like it will be very slow. So we figured out like you don't need to initialize HTTP client every time.
Sockets you're talking
Sockets,
about.
sockets. Yes. I was talking about sockets.
Yes.
So we figured out that you don't need to initialize HTTP client every time. You just need to do it once, and you can just call the method any one time, so that it will just use the one TCP socket and then like make the calls using that.
Yeah.
So it's not just about memory management that comes into play when you're talking about like how things should be allocated. If you're talking to hardware, could be network, could be I/O, could be anything. You need to be very careful with that, right?
Absolutely. And more often than not, it is, the issue lies in a place that you will never think of, it would be the last place that you would, have a suspicion over.
And this will happen during demo time. When you have a demo,
Yeah, I think it's like the printer, right? When you have just a few seconds and you want to get a printout, the printer will never work.
No, okay. So yes. It used to work on a machine. Now it's not going to work. Right?
Yeah, they can feel the fear that we have.
Yeah, true. So, but it's very interesting insight on how everything works. Like you mentioned that it's even though like this heap and stack is a very basic concept, but having basic concepts is very essential.
Absolutely.
I have realized that in a very first-hand experience because we in TechKraft, like we as we talk, like we train many engineers, and one of the programs that we do is actually Cloud Apprentice program. I think this is the second time I've mentioned this in podcast, but yeah. So what we try to achieve on that is it's a 3 months program where you get to learn GCP, Azure, and AWS. So after 3 months, you'll be able to work on any platform that you want. Not in a very advanced level, but at least you know how things work in every 3 platforms. And the first month, you know what I do. I just give them tasks to create a VM in a hypervisor, create a networking inside that, create a virtual networking inside that, communicate to each another, create an RabbitMQ server inside that, create an Nginx Apache server. Because what I want them to understand is, to understand cloud first, you need to understand bare metal servers first.
Absolutely.
If you know how bare metal server works, you go to any cloud service provider, be it Azure, be it AWS, be it Alibaba, could be Rackspace, it's going to work the same way. But you need to understand the first cloud concept. Now, this is something that most of the engineers try not to care about. They just jump directly to a cloud service provider and do the certificates and it's done. But if something goes wrong,
absolutely,
it works in a machine.
Yeah. Like nobody wants to do the boring job first, right?
Yeah, everyone wants to be everyone tries to be a fancy stuff. This goes similar to machine learning and algorithms. Sorry, the AI stuff.
It does. As you said, right? Everything at the end of the day is being stored as ones and zeros, right? Yes. Either it's there or not there. So if this entire tech industry is working on this very basic concepts of how the data is being represented, I think we should take a lesson from that. The more things we know about, the base of everything that we know about. I think the easier and simple application development gets, but at the very same time, even the debugging of the applications, the RC of the applications becomes way easier. And I think it's like a very deferred reward that you get. So you put in this effort and you don't see the reward at the very same time. And because of that, a lot of people are disheartened to even, try doing that. But I think, more and more focus should be made on this aspect of, covering your bases and learning your bases correctly, because it is going to be immensely useful to you.
Yeah, and this is going to make you stand out of the crowd.
Absolutely.
And this is going to make you not an average, like better than average developer or software engineer.
Yeah.
And for me, I'm so interested in learning how CPU works, how memory works, how hard drive works, how SSD works, how motherboards work. And I'm someone who have blew up so many computers, so I have learned it a very hard way and wrong way. But this has helped me a lot in my career, and I'd like to say that to everyone that you need to focus on basics first.
Absolutely. I think one of the aspects of debugging was something, or doing an RCA was something that I got inspired by. Was trying to play this game. So I'm a very a big fan of these racing games in computers. And back then there was this game called Need for Speed Most Wanted.
Yes.
And it had come out and I had a very low config computer. Like it was a 256 MB memory computer with a 2.4 gigahertz P4 processor, no graphics card at all. And even the loading time for this game was huge. And I found out that, I was meeting the basic requirements, but the game was still it failed to load, and I didn't understand why it was happening for the longest time. And then I found out that, having the basic config is fine. Having the proper disk is fine, but it also depends upon the OS. So I was running Windows XP at that time. And it turned out that XP is not the end of it. Like you also have these lower levels where you have different service packs of Windows XP. And I found out that I was on the service pack 2. And this game required a graphics library, DirectX 9.0C. That was just supported in Service Pack 1.
One?
It was just supported in Service Pack 1. So I had to roll back my Windows. And I'm like, what? I have my entire, Windows setup since 5 years on this, and I can't just change things. Otherwise, my dad would kill me because his softwares are over there. And I got to know about this thing called dual booting a computer. And I'm like, man, is that even possible? And these small things, right? Like when you're not trying to learn how to dual boot, when you're not trying to learn how different service pack works, but when your intention is completely different. I wanted to play a game at the end of the day. And I ended up learning 10 different things because of that. I think that aspect, if we are able to bring that somehow in a very nice way, then that would motivate people and keep them happy to do what they are doing. I think that is one of the aspects that is missing, and people feel lackluster because they don't know what they are striving for. You are earning, that is fine, but what is the thing that makes you happy, brings that smile on your face?
Yes, true. So I think you were very lucky to have that config. My first config of mission, it was 800 megahertz single core processor, 128 MB RAM, 40 GB hard drive, and no graphics card. I still used to play NFS almost under there.
Oh man, I remember the loading time for that game. So they used to have these, the US police cars lights as loading thing. And it used to take 2 to 3 minutes for that one race to be loaded. I used to go and brush my teeth and come back and things would be ready. And those were the times.
Yes. Yeah. So how I understood the concept of CPU cycles?
How?
I used to play GTA 4. Sorry, not GTA 4. GTA 4 is way after GTA Vice City.
Of course.
GTA Vice City. There is a mission around that's A marked, and that's a helicopter, RC helicopter that we have to fly.
Oh boy.
That's the most hardest mission that you can ever find.
I completely agree. You have to take bombs and you have to drop at different levels in the building. And you have to drive that
in 8 minutes, right? Now what happened was the 8 minutes in game was 16 minutes in real life for me. Because something in the CPU cycle or the timing that's going on my CPU was very wrong. That's how I understood how CPU cycle works.
Oh boy. And I would...
Can even imagine.
But you were so lucky that happened.
Yes.
Because that mission was really hard to be finished in 8 minutes.
I say finish in two rounds. 2 tries. Now, going in a very the informative part of this, these are the small things that actually teaches you a lot of lessons, and that's going to be a life learning lesson now. That's how I learned that. And I also learned how if you put a memory stick opposite way, it will burn up the motherboard.
I also learned that, if your memory stick is not working, you have to take a rubber and rub it. And that helps.
Yes. If the display is not coming, memory stick. If the CPU is running too hot, then it's the cooler.
Absolutely.
I used to be someone. I used to be the kid who actually used to go all in my neighborhood and fix computers for free. And I have learned so many things doing that. I have blown up so many computers in my neighborhood. But since I was doing it for free, nobody could say anything to me.
Absolutely. And I can relate to that. I have done that, like been there, done that. And you know what? The people whose computer it is, they would not even care about it. Like we would be the people who would be scared about why is it not working. Like, it's like, having your own kid and you'll be like, no, I have to take care of this, not the other people. And you were so involved in that. But I still remember, staying up all night, trying to just, take a backup or trying to, format the computer and, reinstall the OS. And I think I'm glad that I like these things.
Yes. Me too. Like, you don't know, like, if I come back from school, I would be dragged in someone else home to fix computers. That's how it used to work. My parents got so frustrated that they had to move me in a different place. Because I was just fixing computers all day. And like the other funny story is when you set a BIOS password, you know how to reset it? Remove the CMOS battery, like, because the motherboard needs password to store, because the memories that they have is like what we read in schools is like it's programmable, but if you lose the power, like it will just remove the entire. I exactly don't.
It's a volatile memory.
Yeah, it's a volatile memory. So if you remove the battery, the password will reset, right?
Yes.
So these are the small things that has helped me till this day.
Absolutely. CMOS is something, that is so very true. Like, how can you even imagine that just because the clock is not working because of your battery, your computer will not load up? Like, I never thought that computer had a battery for the longest time.
And if you look at the kids today and like they see a laptop, like they don't even know that the laptop is powered by a different battery and it really doesn't matter. So we are in a second generation but now if you see like the shift, right? We are talking about zeros and ones. Now it's a new shift going around with quantum computing. It's not just 0 and 1 anymore.
Oh man, it's a different world altogether.
Yeah, I really want to like ride on that ship at the very first way, but like it's a very difficult thing being in Nepal and like working in quantums and everything. But next 10 years, it's going to be a different computing industry. Like
absolutely, people are striving to be pioneers at that field, and I don't think we have reached even half. We are not even half. We have just barely begun.
Yeah.
And our greatest accomplishments lie ahead of us, and it makes me glad that we are in this time, like this year, this century, that is focusing so much on that.
Yes.
Like having quantum computers that could sort of mimic how we work, trying to reach that stage. I think it's the next big step that we are going to try to take and probably make. These things are the things that keep us engineers and developers excited every day.
Yeah, true. So, like, have you like seen that happening in like Silicon Valley, like the rush towards quantum computing?
People are striving for that. Like companies like Google, they have their own kinds of supercomputers, and a lot of people are trying to understand how it works. They are trying to emulate how the supercomputer works. We are still, as I said, we have barely begun. But I'm super excited for the day, when we have that thing there in flesh, and we are like the capabilities that feature is going to give us. I don't think we have even fully imagined it.
That's true.
Yeah.
So like if someone wants to start with quantum computing, like there is a emulation tool that Microsoft has created. So you can write code in QSharp, that they call it for like quantum computing programs. And it's a very different paradigm that you need to follow if you are like doing it in a very normal computers than in the quantum computers.
Absolutely. The traditional way of thinking doesn't work when you have, these parallel streams of zeros and ones going around. True. Absolutely.
So we shifted from 32-bit architecture to 64-bit architecture to ARM. Now we have a different world coming up. So we're in ARM world right now. Everyone is racing for ARM.
Everyone is. Apple released their processors, like, the M1 processors, they are based on ARMs, and the kind of efficiency that they are providing, the battery life, and the, and the performance. Every time I think that, we are near that stage that things will get stagnated and, things are getting saturated, something like some or the other door opens up.
Yeah, so like I use an M1 Mac Mini at office right now.
Uh-huh.
And it's so efficient for the price that I got it for. I mean, it blows up my mind that even imagining that performance like 2 years back was like impossible.
Right. Even right now, I feel that we are given a gift that was supposed to be handed to us like 10 years after.
True. And like I'd like to connect to this to the point that when you said like you need to be depreciated from a very normal engineer to like a more than average engineer.
Yeah.
Like there was a case where I was working on a Ruby based application, and then there was a Docker container that we need to spin up, and since ARM based container had to be released by the publisher itself, image publisher, so there was a problem in the Docker container not being spin up. So if you do Docker compose up, it was not spinning up because there was no ARM based containers available there.
So Docker engine could not run over there.
Docker engines, the containers could not run there. And I was working with a developer that was trying to make it up. It clearly said that there is no ARM64 based image available for this particular tag. And he says, I'm having problem, like it's been all day, I couldn't figure out. I look at the log and the message was so clear there. Okay? And I was like, if you don't, either you don't read the message or you don't know what ARM64 is, right? So now these are the small things that actually differentiates between a normal and the excellent developer and software engineers. Like, what are the thoughts on that?
I think like one thing that I've known in my life and which I have absorbed in me is that nothing comes without working hard. Unless you feel the pain, it's really hard to gain. And that is something that engineers these days, there are really good engineers that even I have in my team, like my mentor, the team lead that we have. I consider him as an idol because we would spend like 2-3 hours on an issue, and then he would just jump on the call, and even without having a deeper look, he would be able to pinpoint at the issue, and it would seem magic to you.
Yeah.
And I was completely awed by these sort of occurrences, and then I just asked him like, how do you do it? And all he said was, it's like, that's why I brought it up before. Like, it's about covering your bases, being patient, and he said there's another magic thing. There's a secret sauce to it, but you'll only know that when you have it with you. I don't know what he was talking about, but I think he was hinting at, just working hard and, being passionate about it. Because unless you've tried things 100 times, you would not know the 50 other things that you figured out on the way.
Yes.
And it's so at the end of the day, it's not about solving one thing, but it's about the journey. It's about learning other things that you encounter on the way. And I think that is one of the things that I'm really grateful about being in this field, is that every time I try to, I'm trying to optimize something, I'm trying to solve something, there are like 10 different things that I get to know about. And, that just keeps me pumped up that, hey, it's good, you've reached this stage, and now we have 5 more things to do. Yeah. So I think people should try to have a holistic learning rather than just trying to achieve their goal. And that will sort of equip them with, a lot of different tools for different situations, because you can't just have one tool to solve everything.
Yes.
You can't fix everything with just that. You require, different sizes of tools, different kinds of tools for different situations.
And knowledge how to use that tool.
Absolutely.
Yes. So in this particular instance, I have a very experience that like I have recently faced. So I have like four interns that are working in like building an infrastructure team that I talked about earlier. And then the first thing that I did to them was I gave them a server, install VMware EXXI, and then like just figure out how to install a VM and like just open Apache, open Nginx, and just try to communicate there. It took them 2 weeks to do that. Every time I come downstairs, they say, how to fix this, figure it out. So I'm not going to answer that question. Now, like they were like frustrated for like almost 1.5 weeks. At the end of the 2 weeks, they said, I learned so much, like just trying to figure out how to make this work. And now everything is connected now. If I had given them the solution, they could have done in like 2 days.
Absolutely.
But the 2 weeks time they had taken, they learned about how DNS works, how DHCP works, how networking works, how virtual network works, how web servers works, and how to configure that within just 2 weeks of training program. And like that's the way actually I try to train engineers, because I just pick them up and throw them in the ocean and swim it out yourself. I'm not going to save you.
I'm going to say it out loud. You're a really good mentor.
Thank you very much. So I think we are a bit at the end of the episode itself. So is there any last last message that you want to give the audience and to listen to this podcast?
First of all, I think this is a really, really amazing initiative that you guys have, started off. It has inspired me. Not just for this very thing, but like the overall, intention behind TechKraft. I think that is something like, as we were discussing in the cab ride, right? We are missing that crucial part in our day-to-day life. People are not staying that happy as they used to. And I think we should be figuring that out. And for our case, what it has boiled down for me is to have that ability to, have challenging issues every day. Okay, maybe that's a bit too much, but day to day, you'll have boring days. But at the very same time, you need to have something that doesn't keep you, that keeps you awake, that doesn't let you sleep at night, and to be in an environment that promotes that sort of a culture, that sort of pushes you, that appreciates you for thinking outside the box, is something that I would tell everyone to be at. Like, rather than just looking at one aspect of a job or a place or a living, when you get to experience this, when you get to live to your fullest with all the freedom that you get, like it becomes really, really good. You become happy, and I think you learn a lot. You have that sense of satisfaction at the end of the day, which is one of the things without job becomes boring, and it's really it's a really blissful thing to have. So I would tell people to strive for that.
Yeah, thank you very much, Ronak, and thank you very much for your time being here in the podcast. I hope Nepal has served you very well. I hope you had fun at Pokhara, and I wish you a very safe flight back to home. And it was a very, very, very fun conversation. Like I could take out my core engineering part today in this podcast, and like I thank you very much for that opportunity. And also, if I happen to be in California, I'll obviously meet you again.
Oh man,
and then we can have fun there.
Absolutely.
So waiting for that day. So all right, to the audience, thank you very much for listening to this end. I'm Ravi Mandal, your host at TechKraft Podcast and Director of Engineering at TechKraft. Keep subscribing us and follow us on our social media pages for more insights and behind the scenes content. So until next case comes, like have a great time and have a safe time. Bye-bye.